Hello, this time Decibels Level 1. First question. Right, we have the gain of our block, that's given as 38, in fact minus 38 dB, so this is a large attenuation. The output will be much smaller than the input. We have the output as 6.29 millivolts, and the input we don't know. Well, here we just have to apply the standard formula that the gain of something in dBs is 20 times log to the base 10 of the output voltage divided by the input voltage. And if we just plug in the numbers here, we'll find that minus 38 equals 20 times log to the base 10 of 6.29 millivolts divided by the input voltage that we don't know. To solve this, divide both sides by 20 and take 10 to the power of both sides. That would give me 10 to the power of minus 38 over 20 equals 10 to the power of log 10 of 6.29 milli divided by V in. And since 10 to the power of log 10 of something is just equal to the thing, by properties of logarithms, that's just 6.29 milli divided by V in. And therefore, V in equals 6.29 milli divided by 10 to the power of minus 38 over 20, and that should get us our correct answer. Let's have a go. 6.29 milli divided by 10 to the power of, open brackets, otherwise it will do the calculations in the wrong order, and first take 10 to the power of minus 38 and then divide that whole thing by 20, and that should give us the first one. Next. Right, this one is even easier. We're just being asked to calculate the output based on the input and the gain. Once again, same formula to use. Input 0.4 volts, output we don't know, gain minus 2 dBs. And a reminder that when we're dealing with voltages, then the gain in dBs is equal to 20 times log to the base 10 of the output, which is unknown, divided by the input, which in this case is 0.4. And I should point out that this isn't always true. I'm using the formula 20 log 10 of a voltage ratio because the resistance isn't well defined in the question. Strictly speaking, gain in dB should be 10 log 10 of the power out divided by the power in. But in cases like this, it's difficult to define a power in and a power out, so we just assume that the voltage is proportional to the square root of the power. In other words, the power is proportional to the square of the voltage, and therefore it's 10 log 10 of V out over V in all squared. In other words, 20 times log 10 of V out over V in. Don't forget that, because if you forget that, that can come and bite you later. But for now, when we don't have a well-defined resistance in the circuit, we can assume that the power is the voltage squared and use this formula. So here, the gain is minus 2 dBs. So once again, minus 2 equals 20 log 10 of an unknown divided by 0.4. Divide both sides by 20, take 10 to the power of both sides. I would get 10 to the power of minus 0.1 equals an unknown over 0.4. In other words, the unknown is 0.4 times 10 to the power of minus 0.1. And all I have to do is solve that equation to get my answer. 0.4 times 10 to the power of minus 0.1. Oops. Fine. I'll just do one more, and this is about the only other variation you can get at level 1. The input and the output are known, but the gain is unknown. So, once again, the gain in dB is 20 log 10 of the output, in this case 1.58, divided by the input, in this case 1. And all we have to do is evaluate that, which we could do directly in the answer box. Divided by 1, boom. That's about it for level 1. You're always asked this kind of question with either the input, the output, or the gain unknown. Yep, they're all like that. Shouldn't be too bad then, I hope.